Okay, so this is the first problem of our PowerPoint 6.1 on area in between two curves. This is Michelle, it's high. And we're going to start midway through on APQ number 8. So take a sec, go ahead and find that in your packet. And again, this is the beginning of our last unit, which is area and volume, especially volume. This is the one section on area. Okay, so let's do this problem. Let R be the region enclosed by this graph, that vertical line, and the x-axis. Find the area of R. Okay, so the first thing you want to do, I'm going to let you go and do this on your own in a second. I'll just get you started. Then you'll pause the video, answer the question, or the question will pop up automatically, and then you'll do it. So you want to sketch this. Think about the transformation up, down, left, or right 1. Think about the vertical line, x equals 10. Sketch each, and then you're going to do find the area of R. Okay, so I'll let you do it. All right, and we're back. So this is how you do it. This is your, this is the visual. So actually there's not even a top minus bottom. It's just the top is the function and the bottom is the x-axis, and you go from 1 to 10. The 10 is just like a limit of integration, which makes sense because it's an x value. So you take the integral of that, and I'll show you my work. The answer is 18. If you need to check it, go ahead and pause the video, but I'll move on. Okay. This is APQ 9. What is the area of the region between the graphs of y equals x squared and y equals negative x from 0 to 2? So graph that. This is a top minus bottom situation. Figure out which is top, which is the bottom, and you have your limits of integration right there. All right, and we're back. So the answer is D, 14/3. So the parabola is on top. And then the lines on the bottom, you're going from 0 to 2, so you're finding this area here. And then that's how that looks. Again, you want to simplify that to be a plus x before integrating, etc. Okay, APQ 10. All right, same deal, top minus bottom, and you need to find the limits of integration. Remember, if you're not sure how to find the limits of integration, it's the points of intersection of these two lines. To find points of intersection, you set them equal to each other. So you want to replace y with 5, and then solve, and you get your points. You will get your points of intersection. All right, I'll let you solve it. All right, and we're back. So the points of intersection were plus or minus 2. That's my my picture. The answer is D. Oh, did I show you the answer to that one? I hope not. The answer is D. And you can pause it if you want to look over my work. Okay, the region enclosed by the graphs of y equals x squared and y equals x is which of the following? So that's the image. It's this pretty small area right there. The line is actually on top for this, and the limits of integration are 0 and 1. You could do that by setting them equal to each other. I just know that they both go through 0, 0, and they both go through 0, 1. If you did x squared minus x equals 0, x minus 1, you'd get 0 and 1 also. The answer is 1/6 A. PQ2. All right, this gives you your function to integrate and your limits of intersection, your limits of integration. All right, let's check in. The answer is D. APQ 13. All right, this one. You want to make a sketch. To make my sketch, I know what y equals x looks like. I don't really know what this looks like, so I just plugged in 0 to get the y-intercept, so I could sort of tell. And when you find the limits of integration, I would actually find the limits of integration by setting them equal to each other first, and then making your sketch to see what's on the top and on the bottom. All right, we're checking in. So the answer is C. So when you set them, this is to find the limits of integration. So you replace this y with x, substitute, set them equal to each other. So you get 1 and 3 as the limits of integration. And then I tried to figure out that the line would be on top and the parabola on bottom. Okay, and then I got 1 and 1/3. Now, if you ever mix up your top and your bottom, I don't know if anybody did this, if you ever mix up your top and the bottom, the answer will be the same, just negative 1/3. -1 and -4/3 basically. It'll all, if you mix up your top and your bottom, it's actually not a big deal. The answer will be the same, just have the opposite sign. Just have the opposite sign, that's it. So if you simply mixed up the top and the bottom, you should have gotten -1/3. -4/3, -1 and 1/3. If you didn't, then you actually did some computation wrong. Now let's do this. Here we go. Uh-oh, did you see? I don't know if you saw. Alrighty, so you want to do the regions enclosed by these. So these both go up 8, so just graph a line up 8 and graph a cubic up 8 and figure out their points of intersection, and I'll let you go too. Alright, I knew it was going to be 0 and 1, but I found it. I showed you how you could do it algebraically if you wanted. Obviously this doesn't have anything to do with it because it says the first quadrant. So that's why I only am going from 0 to 1, even though, you know, I have more, I would have this area also between -1 and 0, but that doesn't count. This is the area I'm finding. Okay, again, you really want to simplify before you integrate, so because the 8's actually go away, so definitely simplify before you integrate. If you didn't do that, you're wasting a lot of time. The answer is 1/4 A. Okay, this bottom one is really tough. It's actually a problem from 1969, so I wouldn't worry about it too much. I'm not even going to ask you. I'll have you pause the video if you want to try it, but we're going to go through it just together. So it's the region graphed by 1/x, the line x equals m and x equals 2m. The area is what? So I did some sketches, like this area versus that area versus that area, and I couldn't really tell which one was bigger or not. I tried to do it graphically and I couldn't tell. So then I tried it algebraically. So then I did this work. I actually integrated from m to 2m of 1/x dx. And I got ln of 2m minus ln of m. So ln of 2m over m using my log rules equals ln of 2. So actually that's just a constant. So no matter what m is, you're always going to get ln of 2 in this case. So that means they're independent of m. All right, but that was just for funsies. All right, thank you very much for joining me. All right, bye-bye. See you on the next video. I'm Mrs. Schultz, signing off.